This is a production of Cornell University.
All right, so today we're going to talk about soil mapping. And we talked about soil mapping earlier than later, which personally I think this would be better later in the semester. But we're going to talk about it now because in 2 weeks you guys are going to be going out to do some soil mapping. But this also serves as a nice sort of segue between soil factors and processes and this concept of weathering, where these soils are, and what we're looking at in the landscape. So you've heard my story about glaciation, okay? And you've gotten the weathering spiel, and you've heard me talk about, and you guys have read about soil forming factors, the 5 factors, those factors that are driving soil formation, and the processes that basically exchange between these drivers, right? Okay, well, those characteristics basically distribute soils across the landscape. So if we start talking about distribution of soils across the landscape, maybe we should talk a little bit about mapping of those soils, how we in fact inventory those soils. And the tool that we as soil scientists use, and actually the entire United States and much of the world, is what we call soil taxonomy. But the tool that we actually use to map the things we call soil survey. Okay? And we have a number of different products. Here is a soil survey from the 60s and 70s. This is Tompkins County Soil Survey. You can see that it's really well worn. It's basically a paper copy. The new soil surveys and even the old soil surveys have all been updated, and they're basically all online at this point. Okay, so everything that you have in here you can get online. Okay, but what is a soil survey? It's basically a systematic examination, description, classification, and mapping of soils in any given area. Okay, that's straight out of not the book that you have right now, but it's the same authors. It's like 3 editions ago. Probably in your book this time as well. But basically, it's an inventory of soils. And in that inventory are basically 4 things. One is a map showing the geographic relationships of each soil, where they are and how they are positioned in space. Okay? The second thing is basically a text describing those soils. The third thing is basically a table of physical and chemical data for those soils. And then finally, an interpretation for the various uses. Okay, those are the 4 big things that we have in soil survey. Okay, and if you think about it, this is totally dependent upon the things that we've been talking about already. Soil forming factors, soil forming processes, geomorphology, weathering, and transportation. Okay? The text describing it, this is the stuff that you guys have already started doing in the field. You went out and you took a look at Arkport, and you started describing it. Okay? That description, in your case, is mostly physical, but we can extend it to doing more as well as chemical analysis. And once we have that type of knowledge, we can start making interpretations. We have an understanding of how these soils are distributed, and we have an understanding of how these soils are made. Therefore, we have, in a sense, an understanding of how these soils function. Does that make sense? Okay. Just as a segue here, who produces soil survey? Basically, it's a cooperative effort between the land-grant universities, the federal government, and the county in where the soil is made. Okay, so Tompkins County. Okay, basically the state, New York City or New York State. Okay, a lot of different places to get the soil survey. I've already mentioned 2 of them. You can get them from the USDA or the NRCS. You can get them from the Cooperative Extension, as well as the experiment stations. And now you can also get them online. They're also often present in the county libraries. Okay, so what are in these products? First, it's the map. Second, it's the characterization of the units. We call them mapping units, and I'll talk about what they are in a second. It's the classification of each one of these units. Okay, it's the correlation of this soil, so Tompkins County, this soil survey, to all the surrounding counties, and all of those surrounding counties to the rest of the state, and then from the state to the rest of the country, okay, to every other state. Okay, because you don't want to have a map unit that's here that's basically the same soil someplace else, yet we're calling it something different here. Okay, and then the interpretations for suitability of a variety of different uses. Okay, so what are the mapping units? Colloquially, we just call these map units. But mapping units are basically a collection of areas which have similar defined soil properties. Okay? That's the key thing here, because due to these similar soil properties, we can make interpretations similarly across these different soils within this map unit. Okay? So I have a map unit. Similar soils are within this map unit, and we'll talk about what similar soil means in a moment. Okay? And if I have everything within this map unit basically being the same or similar, I can make interpretations that are similar for that map unit. I know that's sort of circular, but does that make sense? Yeah? Okay. Map units have a code. It's a 2-letter code with a third letter that usually tells us a slope. But as a 2-letter code, it's capital and then a lowercase. And then it's followed by a third code, sometimes actually more. Basically a capital letter from A to F that basically describes the slope. I've got 2 examples here, but you guys just experienced this last one, which is the Arkport Fine Sandy Loam. So the AR stands for the Arkport with a 2 to 6% slope, a B slope. Okay? And this is what these maps look like. Okay, this is a comic version of it. But the first 2 letters, CE in this case, that's the name of the soil, and B is the slope. So in this case, a 2 to 6%, or 2 to 5, or depending upon what the code stands for. Does that make sense to everybody? Okay, okay, go. There are exceptions to this rule, but we haven't gotten to them yet. But thanks, that's a good point. I will remember to talk about that. And it's not only just, sometimes it's more, sometimes it's less. Okay? Okay, so how are these units actually made? How do we actually come up with this map unit? Well, we basically take the pedon. Okay, do you guys remember what the pedon is from reading? Basically, this is the soil that it is the identifiable soil of this unit. Okay, so this is all of the characteristics for this type of soil, whatever it happens to be. So imagine this being an Arkport. Okay, if this was an Arkport, we have that AP with a BW and a series of EBTs, right, going all the way down to a C. Okay, well, you guys in that soil pit only looked at one little section of a larger unit. Okay, you were basically looking at the profile of a pedon. Okay, so you were looking at this face. Can you imagine that? Okay, the reality is you know that there were a lot of these little units that were characteristically this soil scattered in that whole area. I mean, that's why I just showed you that map, that sort of deltaic sand section. Okay? Well, these guys can then be grouped, so you basically have a polypedon, or what we call a soil individual. All of these pedons within this soil individual are similarly characteristic. That does not make sense. They have similar characteristics. Does that make sense? Okay? We call that our polypedon or a soil individual. This soil individual then becomes the map unit, which then fits into the landscape. Cool? And hence, we get back to the comic book. Okay? Questions so far? Go.
If the polypedon is all the same as what it's made out of, the individual pedon, why do you make up a smaller?
No, that's a good question. So if all of these polypedons are made up of this, why do we not just use this one unit? Is that basically? Well, the reality is that this is not exactly the same as every one of these other ones. Okay? This is a good, technically, I don't want to do the technical term of this. This is a representation of an Arkport. It represents all the variation of, not all the variation, it doesn't represent all the variation, but it represents some of the variation of this Arkport soil. This pedon that's right here, could be right next to it, could be a slight variant. It's still an Arkport. This soil right here could be a similar variant, but in fact, it might not be an Arkport. Yet, it has similar properties that we can group them together as a map unit. So we call it a soil individual. Okay? This is the Arkport. In all likelihood, everything else that's in here is an Arkport as well. But there may be something that's not exactly an Arkport. Yet it's still similar characteristics. We group it into the soil individual. Does that make sense? Okay. Go.
Are all pedons the same diameter?
No. This pedon, technically this can be basically a meter to basically 10 meters. Something, and basically that unit represents the variant of that individual. I.e., so if I looked at everybody in this room, I could say you're a pedon and you're a pedon. You both could be the same in the same polypedon, but you are obviously different people. Does that make sense?
So it doesn't matter if they're
No. Generally, all the arc ports are going to be the same size, but if I get this soil over here, it might have a 10 meter. So that's go.
How much variation is allowed amongst pedons?
Unlike people, we are not discrete. So what we do is we make art, and they're not necessarily arbitrary, but we create ranges of characteristics within which this soil fits. Okay, so whatever those boundary conditions are. And in some cases, for some soils, that range of characteristics can be rather broad. In some cases, it can be rather narrow. Does that make sense to everybody? Okay, we haven't actually started talking about that, and we will later in the semester. But if you think about what a soil is, a soil represents a concept that we have created of how this soil was created and the characteristics within which this soil operates. Okay, that concept can range based upon our ideas. Okay, so if I have an arc port, it could be a very narrow range of characteristics. On the other hand, the Marden, and you'll see this next week, can have a very wide range of characteristics. The range of soil textures can be wide. The range of soil colors can be wide. The range of horizonation can be wide. Arc port, fairly narrow. But you guys have seen those EBTs, so there is actually a fairly large range of how those EBTs behave. Does that make sense? Kind of? Questions on that? Okay, cool.
This has been a production of Cornell University, on the web at cornell.edu.